Let's take a look at this problem. This problem deals with index of refraction and more specifically refracting of light. So we know that light bends when it goes from one index of refraction to another. The way that we solve a problem like this, the problem reads that we have a diagram that shows a passage of a ray of light from air into a substance X. The index of refraction of X is what? Well, we know that air has an index of refraction of approximately equal to 1. And we know that the equation we use to describe this motion is Snell's law. It says n1 sine theta 1 is equal to n2 sine theta 2. Or the index of refraction of the first substance times the sine of the angle in that substance is equal to the same for the second substance. When we deal with this angle theta, we got to remember that our angle is measured from the normal. So we have our surface, and we have perpendicular to the surface, and we want to measure from the perpendicular, from the normal. So the two angles that we're using are 40 degrees and 20 degrees. So we know that n1 sine theta 1 is equal to n2 sine theta 2. We know it's n1 sine theta 1 over sine theta 2 is going to be n2. I want to figure out what the index of refraction is of X. Well, the index of refraction of air is 1 times the sine of the angle of 40 degrees divided by the sine of the angle of 20 degrees. And that is going to give us the index of refraction of 2, or of the second one. Well, I know that I'm going to just make some approximations here. I don't actually have a calculator in front of me, but I know that the sine of the angle of 40 and the sine of the angle of 20, I know that the sine of the angle of 40 is going to be larger than the sine of the angle of 20. So that means I can actually eliminate out two of my answers. And you know my sine function looks like this. At 90 degrees, it's at a value of 1. For the beginning part, it looks like it's almost a 1-to-1 ratio. So for every increase, if I double the first one, I think the right answer is C. As I get further up, even though I doubled the sine, I'm not doubling how much it goes. It gets a little bit less of it. So I think the angle is twice as much. The sine of the angle is going to be a little bit less than twice as much. So 1.9 is the value. You can check my math by plugging in the values for this. The more important thing to remember is that we deal with the angle measured off the normal, and we use Snell's law to solve this.